All right, so this one, they've given you all the steps. All they're asking you to is justify the steps, right? And so for this first one, they say that you're given segment PQ is congruent to segment TQ, segment UQ is congruent to segment QS. They want us to prove that segment PS is congruent to U. So here's a good step here. When you have a handout like this and you have some congruence, mark your picture, all right? It helps you. So the congruent marks are PQ is congruent to TQ. And that one little dash means that those two are congruent. Match the dashes up. One dash to one dash, those are congruent, all right? They've also told us UQ is congruent to QS. So you'll notice I have two dashes there, 2 dash to 2 dash. That tells me those are congruent. So if you have a handout, you don't want to do this in your book, but on a piece of paper, you want to mark it and say, okay, I can see what is congruent to what. All right, what they want us to prove is that the entire line segment is congruent to the other one. All right, and so just thinking about, you have a piece and a piece congruent, a piece and a piece congruent. You know you can add the pieces because you want to get to the whole piece, right? And then maybe you can do some subtraction in there to get the pieces by itself that you want, or maybe some substitution or transitive property. All right, and so you have to start thinking about, how am I going to get from here to there? And so as soon as they start giving you pieces of a line segment, you're going to think, oh, segment addition postulate. All right, so what do I have equal? Can I do some substitution? And so you're going to start thinking about that so that you can then get to the final, which is the long segment congruent to the long segment. All right, in this case, they've given you every step, so you're really just having to justify it. But eventually you're going to have to do the steps as well. First step is very simple. Why do you always know the first step in a proof? Yeah, your first step is almost always going to be given. There's not much you can go from if you haven't told us what you already know. So hopefully everybody got this one. This one is given. All right. Now, what did they do from step 1 to step 2? They just went from congruence to equality, right? What tells us we can go from congruence to equality and from equality to congruence? The definition of congruence. All right, we have the definition of congruence. Now they start throwing in new things here. Now they've just said, well, PQ plus QS equals PS, TQ plus QQ equals TU. So they've just said from P to Q and Q to S equals the whole, and from T to Q and Q to U equals this whole. What rule or postulate or definition tells us that we can do that? What rule or postulate or definition tells us that two pieces of a segment add up to the whole segment? So go back to the first thing that you have, this piece. What rule or definition or postulate tells you that you can add parts of a segment to get the whole segment? So all they did is they added up two parts of the whole. That's the segment addition postulate. So segment addition postulate tells us that we can add the pieces up. Segment addition postulate. Segment addition postulate. All right. Now let's look at what they did here. All right. So here, instead of saying TQ plus QU equals TU, they have said, or instead of saying PQ plus QS equals PS and TQ plus QU equals TU for these two, they have replaced PQ with TQ. All right. So they've replaced this piece of it with what it equals, and they've now said that TQ plus QS equals PS. And then over here, instead of saying TQ and QU, they've replaced QU, which is this guy, with QS. What did they do for both of these steps? They replaced just one little piece of their equations right here. Substitution tells us we can replace a piece. So both of these are substitution. Both of these are substitution. Now here, we have gone full circle here pretty much. PS equals TQ and QS. TQ, QS equals TU. So PS equals TU. what did they do here? They said PS equals this equals TU, so PS equals TU. What rule tells me if I have A equals B and B equals C, then A equals C? What? Yeah, so I went from PS to the TQ plus QS, the TQ plus QS to TU, then I went straight from PS equals TU. That is transitive property. That is your transitive property.
Would substitution work there?
Yeah, I would actually take substitution because technically you could just say I am substituting this piece with this piece. So I would take either right here.
I have substitutions.
All right, this last step, what did they do? They went from equality to congruence. What tells me I can go from equality to congruence? Definition of congruence. All right, so we have something very, very similar to what you just did. All right, very similar to what you just did here. They gave us that WY, WY is congruent to WZ, and they've given us XY is congruent to VY. Looks almost identical. We are trying to prove the larger ones equal each other. They actually did this almost in the same way. So I think it's almost exactly, except they did some segment addition other places besides there. So this one, they just split up the steps, but you can see they solved it a different way, but it's still a valid solution. And I think this is what throws people sometimes with proofs. You can have two people do the proof different ways, but still prove them logically. All right. So not every proof is going to look exactly the same. It's not like an algebra problem where you add and subtract first, then multiply and divide. All right. These are, you can potentially do them different ways and in different steps and still prove going from step to step. So for this one, what was their first? What did they tell me at first? It's given, right? They told us that those segments equal each other. And then again, they went from congruence to equality. What did they do? Definition of congruence. Now they have told us that XY plus YZ equals XZ. XY plus YZ equals XZ. What tells me I can add two pieces of a segment to the whole segment? Segment addition postulate. All right. Now they have VY plus YW equals XZ. What did they do there? So, yes, we replaced XY with VY. We replaced YZ with WY. So we replaced these two pieces with that. This would not be transitive. This could only be substitution here. All right, substitution here. Now they've told us that VY plus YW equals VW. How do we know that VY plus YW equals VW? The two pieces of the segment add up to the whole segment. Why do we know that? Two pieces of the segment add up to the whole segment. Segment addition postulate. Now they have, there's two possible answers here, right? Again. So here we have that XZ equals this, and this equals VW. So then XZ equals VW. So what rule tells me if A equals B and B equals C, then A equals C? A equals B, B equals C, so A equals C. What rule tells me that? Transitive property. All right. And then on the last step, they went from equality to congruence. How do you go from equality to congruence? Definition of congruence. There you go. When we read the given, we see some key things. E is the midpoint of AC. And then they've given us an equality statement here. All right, an equality statement here. So, keywords in your given, midpoint, all right? Keyword in your given is midpoint. Anytime you see a keyword, you're going to use the definition of that word almost every time. Rarely are they going to give you a word that you have a definition for and you're not going to use the definition. And so you see that we are going to use definition of midpoint. For this particular one, they've given you some statements and they've given you some reasons. And so if you have the statement, you are giving the reason. If you have the reason, you're then giving the statement. All right, so you're just filling in kind of the missing blank. So first one is easy. Why do we always know the first? E is the midpoint of AC. Why do we know that? That is given. Now, definition of midpoint. If E is the midpoint of AC, what does that tell us about these line segments? If E is the midpoint of this, what does that tell us? What do we know? If this is the midpoint, then AE equals EC because it's right in the middle. That's what midpoint means. So for definition of midpoint here, we are going to say, well, because of the definition of midpoint, A to E equals E to C. All right, the third step, they're telling us we're going to go back to our given. We have not used all of our given information. What's the other piece of information that we know from our given? Right, so DE also equals EC. Those also equal EC. So then if we know that AE is equal to EC and DE is also equal to EC, then we can assume that AE is equal to DE. Why can we assume that? What can we do? Substitution, or I will take transitive here. All right, I will take substitution because all you did was you substituted in AE, substituted in for EC. Or you could say AE equals EC, EC equals DE, so AE equals DE. So I will take either substitution or transitive there. Substitution or transitive there. All right, let's look at the next one. The next one, they want us to use the definition of congruence. We have that AE equals DE. What does the definition of congruence tell us then? Right, that it's congruent. So we're going to add our notation for line segments. We're going to change this to congruence. The reason we would do that is because of what we're trying to prove. We're trying to prove that line segments are congruent to each other. So we are eventually going to have to put it back to congruence, all right, which is why we're doing this. This last step, so it looks like we've already proven what we're trying to prove, right? We've proven that AE is congruent to DE. That's not what they ask us, though. It is very specific. They actually ask that we tell them that DE is congruent to AE. So what tells us we can just flip-flop those?
Symmetric.
Yeah, my symmetric property. So hopefully everyone got the first one. What's the first one? That's given, right? Given. All right, so this one is given. Now, how did they get rid of that 1/2? What did they do? They multiplied both sides by 2. What property tells you you can multiply an equation by the same thing on both sides? The multiplication property of equality. The multiplication property of equality. All right. Now, you don't necessarily then have to go from step 2 to step 3, okay? We have exhausted kind of what we need to do right now with those pieces. Now we need to start looking at the whole segment because our goal is to prove that S is the midpoint. So this is where it tells you to work backwards sometimes. They've given you this random piece of information, it seems like, okay? And they want you to prove that S is the midpoint. So in your mind, you need to think, okay, I'm proving S is the midpoint. So somehow I have to prove that RS equals ST, because that's what midpoint means. So somewhere I need to get those equal to each other. So I need to add those up to the whole so that I can somehow replace some of this. So the segment addition postulate goes back to your picture here. what does the segment addition postulate tell you about this long segment? Right, the two pieces add up to the whole. So RS plus ST equals RT. RS plus ST equals RT. All right? Now let's see what they did here. They said that 2RS is RT. All right? And then they have, instead of RT, they have 2RS equals RS plus ST. What have they done here? Substitution, I would take transitive 2, because if you look at it, we have 2RS equals RT, RT equals this addition, so 2RS equals the addition. So I would take substitution or transitive there. So transitive property or substitution. Either one of those are fine, all right? Now let's look at this. We now have 2RS becomes 1RS. RS plus ST becomes just ST. What did they do to both sides of this, Preston? Yeah, they subtracted RS from both sides. What rule tells me I can subtract something from both sides of an equation? The subtraction property. All right, for this last one, your last statement will always be what you're trying to prove, because that's when you know you're done. You're done when you have written what you're trying to prove. And so here you have that RS equals ST. What does that tell you about S? That S is the midpoint of RT. And that is your final statement. S is the midpoint of RT. All right, so first let's talk about what they gave us. Y is the midpoint of XZ. So they have told us that this point here is the midpoint. That's all they have given us. What do they want us to prove? They want us to prove that XY is exactly 1/2 of the total. Now that is common sense. If it is the midpoint, then it should be exactly half of the total. But we have to walk through the process of proving it, okay? So we are definitely going to use what definition? What definition you think we're going to use? Yeah, midpoint. Anytime they give you this guy here, you are going to define it for me and tell me what it tells you about that picture, okay? We are likely going to have to do segment addition because we're going to probably have to divide somewhere to get that 1/2, okay? So we're going to use midpoint. We're going to use segment addition, all right? Because we're going to use midpoint and segment addition, we're likely going to use substitution, all right? And so we're going to walk through this process of how do I get from what they gave me to what they want, all right? How did they get from what they gave me to what they want? All right, so the first step is very easy. My statement is easy and my reason is easy. What do you think those are? Yeah, the given. And so I'm going to write Y is the midpoint of XZ. And we know that because they gave it to us. And so that is given. Now at this point, if you're like, I don't know what to do, this is where you want to give me a definition, okay? So we want to go back to this midpoint word and we want to use the definition of midpoint. We want to use the definition of midpoint because that is all they gave us from the given that's going to help us do anything. So definition of midpoint. They told us it's the midpoint. Then what does the definition of midpoint tell us about this picture? What two segments are equal then if that is the midpoint? XY and YZ. So XY equals YZ. We know that because of the definition of midpoint, okay? Now, if I am trying to say that the two pieces, that the piece by itself, XY, is half of the whole, then I'm going to have to somehow define what the whole is, okay? The whole segment is two pieces added together, right? So what two pieces add together to give me that whole segment? Yeah, if I add those two up, I am going to get the whole. So if I add up my XY and my YZ, then I should get my xz. Why do I know that? Segment addition postulate. This is one we're gonna like dream about. Segment addition postulate. All right, segment addition postulate. Now what I'm really trying to do is relate the whole piece to just the one, just the xz. So I really don't need the yz in there at all, do I? I really just need the xz in there because I'm trying to relate how the xz is related to the whole. So I want to get rid of this yz. What can I put instead of that? What can I put instead of yz? xy. Why can I do that? Substitution. They equal each other. xy plus xy equals xz. I can do that because they equal each other, so I can use substitution here. I can use substitution. So yeah, on the left-hand side, I have xy plus xy. What's an easier way to write that? 2xy. Why can I do that? What rule tells me that? Just simplifying, right? Combining like terms tells me I can do this. So that is just to simplify. I am just simplifying here. So I technically want xy equals 1/2 xz. Now that's multiplied there, so we're dividing by 2. What's another way to say dividing by 2? It's multiplying by what? Or 1/2, since that's how they wrote it in the proof, right? So if I multiply both sides by 1/2, right? 2xy equals 1/2 xz. What tells me I'm allowed to do that? What tells me I can multiply both sides by 1/2? What rule? Multiplication property of equality. So this is why it helps to always pay attention to what you're trying to prove. Because I'm really trying to prove it equals 1/2. So instead of using division here, I'll use the definition of division, which is multiplication.
Why don't you just use
So my last step here is just to rewrite it, which is simplifying it. So we just have that xy equals 1/2 xz. And all I did was simplify. Because we know that AC equals DF, we can substitute in here. We can say instead of AC, we'll write this, and instead of DF, we'll write this. So we have that AB plus BC equals DE plus EF, and that is by substitution. We are trying to prove that AB is congruent to EF. We know that these two equal each other. So I'm going to substitute in, instead of DE, I'm going to write BC. So I'm going to say AB plus BC equals BC plus EF. And that is also substitution. now I can subtract BC from both sides. So I can say that AB plus BC minus BC equals BC plus EF minus BC. That is just my subtraction property of equality. I'm going to simplify that. And I'm going to say, well, when I simplify that, I'm just going to get a B. When I simplify these, I will just get EF. And that is just simplifying both sides. And then I can go to my final piece, which is line segment AB is congruent to line segment EF. And that is definition of congruence.